took part in the program, including intensive noise reduction trials, and including text-based ATC communications and cabin hygiene and cleansing tests related to the COVID-19 pandemic. After removal of the test equipment, the aircraft was delivered to Etihad Airways. In April 2023, Boeing announced the Echo Demonstrator Explorer program, which would run alongside the Echo Demonstrator program. The first Explorer program in 2023 tested international route planning, trajectory-based operations, a major aim of the FAA's Next-Gen project, and maximization of sustainable aviation fuel use for a planned 10% fuel efficiency gain, using a 787-10. Operators, edit. This section needs to be updated. Please help update this article to reflect recent events or newly available information. June 2024. Main article, list of Boeing 787 operators. There are 1,006 Boeing 787 aircraft in airline service as of February 2022, comprising 377 787-8s, 568 787-9s and 61 787-10s, with outstanding orders for further 481 aircraft. As of August 2019, the largest operators are All Nippon Airways, 77, United Airlines, 63, Japan Airlines, 47, and American Airlines, 46. Orders and deliveries, edit. Main article, list of Boeing 787 orders and deliveries. In September 2011, the 787 was first officially delivered to launch customer All Nippon Airways. As of December 2018, the top 5 identified 787 customers are American Airlines with 89 orders, 37-8s and 52-9s, All Nippon Airways with 83 orders, 36-8s, 44-9s and 310s, ILFC, an aircraft leasing company, with 74 orders, 23-8s and 51-9s, and United Airlines, 12-8s, 38-9s and 21-10s, and Etihad Airways, 41-9s, 30-10s, both with 71 orders. On the 13th of December 2018, the 787th Boeing 787 was delivered to AerCap and leased to China Southern Airlines. By then the 787 had flown 300 million passengers on 1.5 million flights and opened 210 new non-stop routes. The 1000th Dreamliner, a 787-10 for Singapore Airlines, made its maiden flight on the 3rd of April 2020. Boeing 787 orders and deliveries by type. Total orders, total deliveries unfilled. 787 to 8 431 397 34. 787 to 9 1263 647 616. 787 to 10 263 117 146. Total 1957 1161 796. Boeing 787 net orders and deliveries by year. 2021, 2022, 2023, 2024 total. Net orders 11 114 301 48 1957. Deliveries 787 to 8 29 10 1 397. 787 to 9 12 10 40 29 647. 787 to 10 12 23 21 117. Total 14 31 73 51 1161. 2004 2005 2006 2007 2008 2009 2010 2011 2012 2013 2014 2015 2016 2017 2018 2019 2020. Net orders 56 235 157 369 93 59 4 13 12 182 41 71 58 94 109 82 20. Deliveries 787 to 8 3 46 65 104 71 35 26 10 10 5. 787 to 9 10 64 102 110 120 114 36. 787 to 10 15 34 12. Total 346 65 114 135 137 136 145 158 53. Boeing 787 orders and deliveries, cumulative, by year. Orders. Deliveries. Orders and deliveries as of December 2024. Accidents and incidents, edit. The Boeing 787 has been involved in 7 accidents and incidents as of September 2024, with 0 fatalities and no hull losses. Operational problems, edit. A Japan Airlines, JAL, 787 experienced a fuel leak on the 8th of January, 2013, and its flight from Boston was cancelled. The next day, United Airlines reported a problem in one of its 6787s with the wiring near the main batteries. Soon, the U.S. National Transportation Safety Board opened a safety probe. Fuel leaks also occurred on the 11th of January, 2013 and on the 13th of January, 2013, at Narita International Airport outside Tokyo. The aircraft reportedly was the same one that had a fuel leak on January the 8th. Japan's Transport Ministry also launched an investigation. On the 11th of January, 2013, the FAA completed a comprehensive review of the 787's critical systems, including the design, manufacture, and assembly. The Department of Transportation Secretary Ray LaHood stated the administration was looking for the root causes behind the recent issues. The head of the FAA, Michael Hutar, said that so far nothing found suggests the 787 is not safe. On the 12th of July, 2013, a fire started on an empty Ethiopian Airlines 787 parked at Heathrow Airport before it was extinguished by the Airport Fire and Rescue Service. No injuries were reported. The fire caused extensive heat damage to the aircraft. The FAA and NTSB sent representatives to assist in the investigation. The initial investigation found no direct link with the aircraft's main batteries. Further investigations indicated that the fire was due to lithium manganese dioxide batteries powering an emergency locator transmitter, ELT. The UK Air Accidents Investigation Branch, AAIB, issued a special bulletin on the 18th of July, 2013. Requesting the US FAA ensure that the locator is removed or disconnected in Boeing 787s and to review the safety of lithium battery-powered ELT systems in other aircraft types. On the 19th of August, 2015, the Associated Press reported that the fire was started by a short circuit caused by crossed wires located under the battery. The Air Accidents Investigation Branch's investigators recommended that the U.S. Federal Aviation Administration, together with similar bodies in Europe and Canada, should conduct a review of equipment powered by lithium metal batteries to ensure they have an acceptable level of circuit protection. On the 26th of July, 2013, ANA said it had found wiring damage on two 787 locator beacons. United Airlines also reported that it had found a pinched wire in one 787 locator beacon. On the 14th of August, 2013, the media reported a fire extinguisher fault affecting 3 ANA airplanes, which caused the fire extinguishers to discharge into the opposite engine from the one requested. The fault was caused by a supplier assembly error. On the 22nd of November, 2013, Boeing issued an advisory to airlines using General Electric GEnx engines on 787 and 747-8 aircraft to avoid flying near high-level thunderstorms due to an increased risk of icing on the engines. The problem was caused by a buildup of ice crystals just behind the main fan, causing a brief loss of thrust on 6 occasions. On the 21st of January, 2014, a Norwegian Air Shuttle 787 experienced a fuel leak which caused a 19-hour delay to a flight from Bangkok to Oslo. The leak became known to pilots only after it was pointed out by concerned passengers. It was found later that a faulty valve was responsible. This fuel leak is one of numerous problems experienced by Norwegian Air Shuttle's 787 fleet. Mike Fleming, Boeing's Vice President for 787 Support and Services, subsequently met with executives of Norwegian Air Shuttle and expressed Boeing's commitment to improving the 787's dispatch reliability. "We are not satisfied with where the airplane is today, flying at a fleet average of 98%. The 777 today flies at 99.4%, and that's the benchmark that the 787 needs to attain." In March 2016, the FAA accelerated the release of an airworthiness directive in response to reports indicating that in certain weather conditions erroneous low airspeed may be displayed. There was concern abrupt pilot control inputs in this condition could exceed the structural capability of the airplane. Pilots were told not to apply large, abrupt control column inputs in the event of an unrealistic drop in displayed airspeed. On the 22nd of April, 2016, the FAA issued an airworthiness directive following the 29th of January incident in which a General Electric GEnx 1B PIP-2 engine suffered damage and non-restartable power loss while flying at an altitude of 20,000 feet. The damage is thought to have been caused by a fan imbalance resulting from fan ice shedding. On the 18th of June, 2021, a British Airways 787-8, registration GZBJB, spontaneously suffered a nose gear collapse at London Heathrow Airport while stationary at stand 583. Photographs circulated after the incident showed the aircraft resting on its nose, with some damage to its nose gear door. No passengers were on board, and the flight was in the process of being loaded with cargo for a cargo-only flight from Heathrow to Frankfurt Airport at the time of the incident. The UK's Air Accidents Investigation Branch, AAIB, determined that an incorrectly inserted pin, used during routine maintenance to prevent the gear retracting when the hydraulics are cycled, was the cause of the accident. On the 11th of March, 2024, LATAM Airlines Flight 800 experienced a sudden drop in altitude, resulting in 50 injuries to those aboard and 12 with serious injuries being hospitalized. As of the 13th of March, 2024, the cause is still under investigation. Lithium-ion battery problems, edit. Main article, Boeing 787 Dreamliner battery problems. On the 16th of January, 2013, All Nippon Airways Flight 692, en route from Yamaguchi Ube Airport to Tokyo Haneda, had a battery problem warning followed by a burning smell while climbing from Ube about 35 nautical miles, 65 kilometers, 40 mi, west of Takamatsu, Japan. The aircraft diverted to Takamatsu and was evacuated via the slides. 3 passengers received minor injuries during the evacuation. Inspection revealed a battery fire. A similar incident in a parked Japan Airlines 787 at Boston's Logan International Airport within the same week led the Federal Aviation Administration to ground all 787s. On the 16th of January, 2013, both major Japanese airlines ANA and JAL voluntarily grounded their fleets of 787s after multiple incidents involving different 787s, including emergency landings. At the time, these 2 carriers operated 24 of the 50 787s delivered. The grounding reportedly cost ANA some 9 billion yen, $93 million, in lost sales. On the 16th of January, 2013, the FAA issued an emergency airworthiness directive ordering all American-based airlines to ground their Boeing 787s until yet-to-be-determined modifications were made to the electrical system to reduce the risk of the battery overheating or catching fire. This was the first time that the FAA had grounded an airliner type since 1979. Industry experts disagreed on consequences of the grounding. Airbus was confident that Boeing would resolve the issue and that no airlines will switch plane type, while other experts saw the problem as costly and could take upwards of a year. The FAA also conducted an extensive review of the 787's critical systems. The focus of the review was on the safety of the lithium-ion batteries made of lithium cobalt oxide, LiCu2. The 787 battery contract was signed in 2005, when this was the only type of lithium aerospace battery available, but since then newer and safer types, such as LiFePO4, which provide less reaction energy with virtually no cobalt content to avoid cobalt's thermal runaway characteristic, have become available. FAA approved a 787 battery in 2007 with 9 special conditions. A battery approved by FAA, through Mobile Power Solutions, was made by Rose Electronics using Kokum cells. The batteries installed in the 787 are made by USA. On the 20th of January, the NTSB declared that overvoltage was not the cause of the Boston incident, as voltage did not exceed the battery limit of 32 V, and the charging unit passed tests. The battery had signs of short-circuiting and thermal runaway. Despite this, by the 24th of January, the NTSB had not yet pinpointed the cause of the Boston fire. The FAA would not allow U.S.-based 787s to fly again until the problem was found and corrected. In a press briefing that day, NTSB Chairwoman Deborah Hersman said that the NTSB had found evidence of failure of multiple safety systems designed to prevent these battery problems, and stated that fire must never happen on an airplane. The Japan Transport Safety Board, JTSB, said on the 23rd of January that the battery in ANA jets in Japan reached a maximum voltage of 31 V, below the 32 V limit like the Boston JAL 787, but had a sudden unexplained voltage drop to near zero. All cells had signs of thermal damage prior to runaway. ANA and JAL had replaced several 787 batteries before the mishaps. As of the 29th of January, 2013, JTSB approved the use of factory quality control while the NTSB examined the Boston battery for defects. The failure rate, with 2 major battery thermal runaway events in 100,000 flight hours, was much higher than the rate of 1 in 10 million flight hours predicted by Boeing. The only American airline that operated the Dreamliner at the time was United Airlines, which had 6. Chile's Directorate General of Civil Aviation, GIC, grounded LAN Airlines 3787S. The Indian Directorate General of Civil Aviation, DGCA, directed Air India to ground its 6 Dreamliners. The Japanese Transport Ministry made the ANA and JAL groundings official and indefinite following the FAA announcement. The European Aviation Safety Agency also followed the FAA's advice and grounded the only 2 European 787s operated by LOT Polish Airlines. Qatar Airways grounded their 5 Dreamliners. Ethiopian Airlines was the final operator to temporarily ground its 4 Dreamliners. By the 17th of January, 2013, all 50 of the aircraft delivered to date had been grounded. On the 18th of January, Boeing halted 787 deliveries until the battery problem was resolved. On the 7th of February, 2013, the FAA gave approval for Boeing to conduct 787 test flights to gather additional data. In February 2013, FAA oversight of the 787's 2007 safety approval and certification was under scrutiny. On the 7th of March 2013, the NTSB released an interim factual report about the Boston battery fire on the 7th of January 2013. The investigation stated that heavy smoke and fire coming from the front of the APU battery case. Firefighters tried fire extinguishing, but smoke and flame size about 3 inches, or 8 centimeters, did not stop. Boeing completed its final tests on a revised battery design on the 5th of April 2013. The FAA approved Boeing's revised battery design with 3 additional, overlapping protection methods on the 19th of April 2013. The FAA published a directive on the 25th of April to provide instructions for retrofitting battery hardware before the 787s could return to flight. The repairs were expected to be completed in weeks. Following the FAA approval in the US effective the 26th of April, Japan approved resumption of Boeing 787 flights in the country on the 26th of April 2013. On the 27th of April 2013, Ethiopian Airlines took a 787 on the model's first commercial flight after battery system modifications. On the 14th of January 2014, a battery in a JAL 787 emitted smoke from the battery's protection exhaust while the aircraft was undergoing pre-flight maintenance at Tokyo Narita Airport. The battery partially melted in the incident. One of its 8 lithium-ion cells had its relief port bent and fluid sprayed inside the battery's container. It was later reported that the battery may have reached a temperature as high as 1,220 degrees Fahrenheit, 660 degrees Celsius, and that Boeing did not understand the root cause of the failure. The NTSB criticized the FAA, Boeing, and battery manufacturers for the faults in a 2014 report. It also criticized the GE-made flight data and cockpit voice recorder in the same report. The enclosure Boeing added is 185 pound, 84 kilograms, heavier, negating the lighter battery potential. Aircraft on display, edit. All 3 prototype 787-8s are preserved in museums. 1N787BA, ZA001, Chubu Centre Airport in Nagoya, Japan, first prototype aircraft. 2N787X, ZA002, Pima Air and Space Museum in Tucson, Arizona, United States, second prototype aircraft. 3N787BX, ZA003, Museum of Flight in Seattle, Washington, United States, third prototype aircraft. Specifications, edit. 787 characteristics. Model 787 to 8, 787 to 9, 787 to 10. Cockpit crew 2. Seating, 2 class 242, 24J at 85 plus 218Y at 32 290, 28J at 85 plus 262Y at 32 330, 32J at 85 plus 298Y at 32. Seating, 1 class maximum 359, exit limit 381, maximum 406, exit limit 420, maximum 440, exit limit 440. Length 186 feet 1 in, 56.72 m, 206 feet 1 in, 62.81 m, 224 feet, 68.28 m. Wing 9.59 aspect ratio, 4,058 square feet, 377 m, area, 32.2 degrees wing sweep. Wingspan 197 feet 3 in, 60.12 m, span, 20.58 feet, 6.27 m, mean chord. Height 55 feet 6 in, 16.92 m, 55 feet 10 in, 17.02 m. Fuselage cabin width, 18 feet 0 in, 5.49 m. External width, 18 feet 11 in, 5.77 m, height, 19 feet 6 in, 5.94 m. Cargo capacity 4,826 cubic feet /136.7 m. 28 LD3 or 9, 88125. Pallets 6,090 cubic feet /172 m. 36 LD3 or 11, 96125. Pallets 6,722 cubic feet /190.3 m. 40 LD3 or 13, 96125. Pallets. Maximum takeoff weight 502,500 pound /227,900 kilograms, 561,500 pound /254,700 kilograms, 560,000 pound /254,000 kilograms. Maximum payload 90,500 pound /41,100 kilograms, 116,000 pound /53,000 kilograms, 126,300 pound /57,277 kilograms. Operating empty weight 264,500 pound /120,000 kilograms, 284,000 pound /129,000 kilograms, 298,700 pound /135,500 kilograms. Fuel capacity 33,340 US gal /126,206 L. 223,378 pound /101,343 kilograms, 33,399 US gal /126,429 L. 223,773 pound / 101,522 kilograms. Speed maximum, Mach 0.90, 516 kn, 956 kilometers per hour. Cruise, Mach 0.85, 488 kn, 903 kilometers per hour. Range 7,305 mi, 13,530 kilometers, 8,410 mi, 7,565 mi, 14